You just finished that snack. Maybe it was a cookie, maybe a can of soda, maybe something marketed as healthy that still had 28 grams of added sugar in it. Whatever it was, I'm going to tell you exactly what is happening in your body right now, at this exact moment, and for the next 20 minutes, because something remarkable just started, and someone engineered it to happen exactly this way. Right now, 0 minutes. The sugar hit your mouth and something interesting happened before you even swallowed. Sweet receptors on your tongue fired immediately, sending a signal to your brain that calories are incoming. Your brain responded by beginning to prepare your digestive system. Stomach acids increasing, pancreas beginning to prime insulin production. Your brain's anticipatory system activated before a single molecule of glucose reached your bloodstream. This is called the cephalic phase response, and it means your brain started responding to the sugar before your body even processed it. 2 minutes in, the simple sugars, glucose and fructose, are crossing through your stomach wall and entering your small intestine, where absorption begins almost immediately. Glucose is entering your bloodstream right now. Blood glucose levels are starting to rise. Your pancreas, which has been waiting for this signal, begins releasing insulin at an accelerating rate. Insulin is the hormone that unlocks your body's cells to receive glucose. Without it, the glucose in your bloodstream cannot be used. With it, your cells begin drinking. 5 minutes in, here's where it gets interesting. Cyclard, your blood glucose level has now risen enough to trigger a significant insulin response. And here's the part the nutrition label doesn't tell you. Insulin doesn't just manage blood sugar, it is also one of the most powerful fat storage hormones in the human body. When insulin is high, fat breakdown is suppressed. Your body cannot effectively burn stored fat while insulin is elevated. And depending on what you just ate and how much, insulin may be elevated for the next 2 to 4 hours. But none of that is why you're going to want another one. 8 minutes in. In your brain's reward center, specifically in the nucleus accumbens, the same region activated by addictive drugs, dopamine is being released. This is the part that was engineered. Dopamine is not the pleasure chemical. It is the wanting chemical. It creates motivation, anticipation, the drive to seek more. And the dopamine response to sugar follows a specific pattern. It spikes on the first hit, and then, this is the key, it drops below your starting baseline on the second hit, which means that to feel the same level of wanting from the second sweet snack as you felt from the first, you need slightly more. This is not addiction in the clinical sense, but it is the same neurological mechanism that creates tolerance in drug users. And the scientists at major food companies, researchers with Neuroscience PhDs working in laboratories studying exactly this response, have spent decades optimizing their products to hit this system as hard as possible. There is a term for the optimal point of sweetness, saltiness, and fat that produces the strongest neurological response. It is called the bliss point. It was coined by a market research scientist named Howard Moskowitz, who spent years running taste tests for food companies. His work helped redesign products like Dr. Pepper, Prego tomato sauce, and dozens of other products you eat without thinking about it. The bliss point is not the flavor you prefer. It is the flavor that most effectively keeps you eating. 12 minutes and your blood glucose is now at or near its peak. You may notice a moment of energy, clarity, the mild, pleasant sensation that follows a sugar hit. This is real. Glucose is your brain's primary fuel, and your neurons are benefiting from the sudden increase in supply. But the insulin has been working this whole time. Your cells are absorbing glucose rapidly, and the pancreas, unable to perfectly calibrate how much insulin was needed, has in many cases over-released. 20 minutes in, here comes the crash. Your blood glucose, which peaked around minutes 8 to 12, has now been brought down sharply, often below the level it was at before you ate anything. This hypoglycemic dip triggers a specific cascade. Low blood glucose signals hunger. Your brain's energy monitoring systems activate an alarm. Cortisol rises slightly. Attention narrows. Irritability increases. Motivation drops. And your brain, which knows exactly what just solved this problem 17 minutes ago, sends you toward the kitchen. This is the cycle, not a metaphor, not a weakness of character, a measurable, reproducible, physiological cycle that repeats until you either eat more sugar, eat something that stabilizes blood glucose differently, or wait out the discomfort. The food companies know the duration of this cycle. They have studied it. They have, in some documented cases, optimized the serving sizes of their products to deliver the crash at the moment when repurchase is most behaviorally likely, which is why a single-serve bag of chips or cookies is rarely enough to feel satisfied, but always enough to want more. What sugar actually does. Over time now, zoom out from your body in this moment and look at the pattern over months and years. The brain's dopamine system has a property called downregulation. When it is frequently overstimulated by sugar, by drugs, by anything that produces a large dopamine spike, it reduces the number of dopamine receptors to compensate. The result is that over time, natural rewards, a walk in the morning, a conversation with someone you love, the completion of a piece of work, produce less dopamine response. They feel less rewarding. This is why people who frequently eat highly processed food often describe whole foods as bland or boring. Their reward systems have been calibrated to a level of stimulation that natural food cannot reach. This is not a personal failing. It is a measurable neurological change that has been documented in fMRI studies comparing heavy processed food consumers to those who rarely eat it. What you can do with this information. Number 1, eat something with fiber and protein before you're hungry. Blood glucose stability begins before the craving. Once the dopamine response is activated and you're already craving, you are making decisions from inside the engineered response. Fighting it at that point is extremely hard. Preventing it from starting is much easier. Number 2, understand the difference between hunger and low blood glucose. Real hunger builds slowly. The hypoglycemic dip hits fast, within minutes, and feels urgent, anxious, hard to ignore. They feel similar, but they are not the same biological event. Drinking water and waiting 5 minutes often tells you which one you're actually experiencing. Number 3, read ingredient lists by weight, not by marketing. No added sugar on the front label is compatible with a product containing 22 grams of naturally occurring fructose. The front of the package is advertising. The ingredients list, sorted by weight, is the actual product. The sugar in your snack did not sneak up on you. It was placed exactly where it is, in exactly the amount it's in, designed with the exact flavor profile it has, packaged in the exact serving size it comes in, and priced at exactly the point it is, by people who understand your brain chemistry better than most of us realize. That's not a reason for guilt. It's a reason for information, and now you have some.